The Finer Points of HAZOP, a guide for engineers. For engineers, safety is always a top priority, and the HAZOP study is one of the most effective tools for identifying and mitigating potential risks in industrial processes. HAZOP, or Hazard and Operability Study, is a structured and systematic approach to examining complex processes and ensuring their safe operation. Today, we'll go over the basics of a HAZOP study, its objectives, key terms, steps, and a step-by-step guide on how to conduct a HAZOP study effectively. What is a HAZOP study? A HAZOP, Hazard and Operability Study, is a risk management technique widely used in industries like chemical processing, pharmaceuticals, oil and gas, and manufacturing. It's designed to identify potential hazards and operability problems within a process, such as safety issues, equipment malfunctions, or environmental risks. HAZOP is an essential part of the Safety Instrumented Lifecycle, SILC, a comprehensive approach to process safety and risk management. Objectives of a HAZOP study. The main objectives of a HAZOP study are two. 1. Identify hazards and risks. The primary goal of HAZOP is to uncover potential hazards that could lead to operational issues or safety concerns. This may include identifying scenarios that could cause injuries, environmental harm, or equipment damage. 2. Recommend measures to mitigate hazards. Once potential hazards are identified, the next objective is to propose effective control measures to mitigate these risks. These recommendations can include additional safeguards, changes in procedures, or equipment modifications. 3. Improve safety and operability. Beyond just identifying hazards, a HAZOP study aims to improve the overall safety and operability of a process. This means making the process not only safer, but also more efficient and reliable. Key terms used in a HAZOP study. To understand HAZOP, it's important to get familiar with some fundamental terms. Hazard. Any potential source of harm or adverse effect on health, safety, or the environment. Risk. The likelihood and severity of harm that can arise from a hazard. Control. Measures put in place to reduce or eliminate the risk posed by a hazard. Steps in a HAZOP study. A HAZOP study involves several key steps which are essential to ensure a thorough and organized analysis. 1. Define the scope of HAZOP. Before the study begins, it's critical to define the scope. This includes deciding which parts of the process will be analyzed and setting objectives for the study. 2. Create a HAZOP team. A successful HAZOP study relies on a diverse team with various expertise, including engineers, safety experts, operations personnel, and possibly external consultants. 3. Conduct the HAZOP study. During this step, the team systematically reviews each part of the process, asking questions and identifying potential hazards and operability issues. 4. Document the HAZOP findings. All observations, findings, and recommended actions should be thoroughly documented. This documentation serves as a reference for implementing safety improvements and as a record for future audits. How to conduct a HAZOP study. Let's break down the process of conducting a HAZOP study into more specific actions. 1. Identify hazards. The team begins by examining each section of the process to identify potential hazards. This step involves brainstorming possible deviations from normal operation, such as equipment malfunctions, leaks, or unexpected reactions. 2. Evaluate hazards. Once hazards are identified, the team assesses the potential risks they pose. This evaluation includes estimating the likelihood of each hazard occurring and the potential consequences if it does. 3. Recommend measures to mitigate hazards. After evaluating risks, the team suggests ways to reduce or eliminate each hazard. These recommendations can range from physical safeguards, like adding emergency shutoff valves, to procedural changes, like enhancing staff training or improving maintenance schedules. Commonly overlooked elements in HAZOP studies and why they matter. HAZOP studies are powerful tools for identifying and mitigating risks in complex processes, but even well-conducted studies can sometimes miss important elements. Over the years, I've noticed some frequently overlooked areas that can impact the thoroughness and effectiveness of a HAZOP study. Here, we'll cover these commonly ignored aspects, explain why they matter, and discuss how engineers can ensure these crucial points aren't missed in their HAZOP process. 1. Human factors and operational errors. One of the most commonly overlooked areas in HAZOP is the potential for human error. Often, studies focus heavily on technical risks while overlooking the role of operators, maintenance staff, and even engineers in day-to-day operations. Why it matters. Human factors can play a significant role in incidents and near misses. Mistakes such as improper valve operation, skipped steps in a procedure, or miscommunication can lead to serious accidents. By accounting for human factors, you can identify scenarios where processes might be unintentionally altered or where complex instructions might lead to misunderstandings. How to address it. Consider involving experienced operators in the HAZOP team and including questions related to procedural steps and human interactions with equipment. For example, ask how easily the process can be misinterpreted or whether instructions are clear and intuitive. Addressing human factors can add an extra layer of safety to your study. 2. Secondary and downstream effects. Another commonly missed aspect is analyzing how hazards might impact other parts of the process downstream. HAZOP studies often focus on specific points without fully considering the broader system and potential chain reactions. Why it matters. A hazard in one section of the process could trigger issues in another, creating cascading effects. For example, an overpressure in one part of a system could lead to leaks, which may cause issues downstream if not contained. Ignoring these connections can result in incomplete mitigation strategies. How to address it. Ensure the HAZOP team considers both direct and indirect consequences of each hazard. Encourage the team to zoom out periodically and ask how a hazard in one area might affect other parts of the process. This can help identify secondary risks that may otherwise go unnoticed. 3. Maintenance and inspection routines. While HAZOP studies typically cover operational risks, they often overlook risks associated with maintenance and inspection. Maintenance routines can introduce hazards of their own, particularly if equipment is not regularly checked, calibrated, or if maintenance is carried out incorrectly. Why it matters. Maintenance and inspection schedules are crucial for keeping equipment in safe operating condition. Poorly maintained equipment or skipped inspections can lead to mechanical failures, increased wear and tear, and even emergency situations. How to address it. Include maintenance personnel in the HAZOP team to provide insights on routine maintenance activities. Discuss the potential hazards that could arise if maintenance is delayed, skipped, or done improperly. Document recommendations for enhanced maintenance procedures and schedules to ensure equipment reliability and safety. 4. Emergency response and shutdown procedures. Emergency procedures are another area that can get overlooked, especially if the HAZOP team assumes that operators are fully aware of what to do in an emergency. Sometimes, HAZOP studies skip evaluating the effectiveness and clarity of shutdown or evacuation procedures. Why it matters. In an emergency, every second counts. If shutdown procedures are confusing, require too many steps, or are difficult to execute, it can increase the severity of an incident. Clear, effective emergency procedures are vital to minimizing damage and protecting lives. How to address it. Review all emergency response and shutdown procedures as part of the HAZOP study. Identify if any procedures could be simplified or made clearer. Make sure to address questions like, is this procedure easy to follow in high-stress situations? Or does everyone on the team know exactly what their role is during an emergency? 5. Unusual operating conditions. Standard HAZOP studies often focus on normal operating conditions, but unusual or transient conditions, such as startup, shutdown, or unexpected surges, can introduce unique risks that might be missed. Why it matters. Transient states like startup and shutdown involve different pressures, temperatures, and flow rates than normal operations, and these can bring their own set of hazards. Ignoring these states can leave the process vulnerable to risks that are unique to these periods. How to address it. Include transient operating states as part of the HAZOP analysis. Take the time to consider what could go wrong specifically during startup, shutdown, or other unusual conditions. Adjustments to procedures or additional safeguards may be necessary to safely handle these conditions. 6. External factors and environmental conditions. HAZOP studies sometimes overlook the impact of external factors such as weather, power supply stability, or external events like fires or flooding that can affect the safety and operability of a system. Why it matters. Environmental conditions and external factors can have a significant impact on process safety. For example, extreme temperatures can affect the performance of certain materials, and power outages could compromise automated control systems. How to address it? Encourage the HAZOP team to consider what-if scenarios related to external conditions. Ask questions like, how would this system respond to a power outage? Or are there risks associated with extreme temperatures or weather conditions? This adds resilience to the HAZOP by considering factors beyond the immediate system. 7. Cross-departmental communication and knowledge sharing. Finally, the lack of cross-departmental communication is a frequently overlooked issue in HAZOP studies. Often, different departments are unaware of how their operations might impact others, leading to communication gaps. Why it matters. Poor communication between departments can lead to misunderstandings and inconsistent practices that create risk. For example, if maintenance schedules aren't communicated effectively with operations, equipment might be used when it should be offline for repair. How to address it? Encourage open communication between departments during the HAZOP study. Invite representatives from all relevant departments to the HAZOP team and facilitate discussions that allow for knowledge sharing. Creating a system of regular communication between departments can help maintain safety standards long after the HAZOP study is completed. Conclusion: taking a comprehensive approach to HAZOP. A thorough HAZOP study goes beyond surface-level analysis and digs into the finer details of how a process operates under various conditions. By paying attention to commonly missed aspects like human factors, maintenance routines, emergency procedures, and external conditions, engineers can create a more robust safety framework. When these overlooked areas are carefully considered, the HAZOP study becomes a powerful tool for identifying and mitigating risks, leading to safer, more reliable processes.